In this lesson, we will be working with algebraic fractions. Please note that you should be able to do your factorization confidently and be able to recognize which factorization methods to use for different algebraic expressions. Before we look at algebraic fractions, let us first revise what we already know about common fractions. The first point is division by zero, or the use of zero. If we divide any number by zero, it is undefined. However, if 0 is divided by any number, the answer is 0. Next, let's look at addition and subtraction of common fractions. As you can see in this example, if the denominators are not the same, we find the lowest common denominator, which in this case is 15, so our answer becomes 11 over 15. When we are multiplying fractions, we multiply the numerators, multiply the denominators, and then simplify the fraction. What we can also do, if there are common factors in the numerator and the denominator, we can cancel that before doing our multiplication. Next is division. With division, we first invert the divisor and multiply. So here we have 2/5 divided by 1 over 5. We change the divide to multiply, and the 1 over 5 becomes 5 over 1. We cancel off the 5s or cross off the 5s, and we're left with an answer of 2. The last point to remember when we did common fractions was that our answer has to be simplified. So whatever answer we get, we needed to divide the numerator and denominator by a common factor. So here 2 over 6, we divided both the numerator and the denominator by 2 to give us an answer of 1/3. Remember, when we are simplifying algebraic fractions, cancel factors and knocked terms. So we have to factorize before cancelling or crossing off any common factors. So in this first example, we have 2x minus 2y divided by x minus y. We cannot cross off the x's and cross off the y's. We first need to factorize the numerator, which becomes 2 into x minus y divided by x minus y. Now we can cancel off our common factors. So x minus y over x minus y is 1, which gives us a final answer of 2. We are now going to do multiplication of algebraic fractions. The strategy that we use is that we first factorize the numerator and denominator and then only cancel our common factors. So this is our example, 2x minus 2 divided by x minus 3 multiplied by x squared minus 9 divided by 3x minus 3. So remember, we have to factorize our numerators, factorize our denominators. So what do we notice? That 2x minus 2 has a common factor. X squared minus 9 is the difference of 2 squares. And in 3x minus 3, we have a common factor. So if we factorize these three expressions, this is what we end up with. Now we can cancel our common factors. So x minus 1 divided by x minus 1 is 1. X minus 3 divided by x minus 3 is 1. What are we left with? 2 into x plus 3 over 3. This cannot be factorized any further, and this is our final answer. Now we look at division of algebraic fractions. This is the strategy that we follow. We invert the divisor and replace the divide by a multiply. Factorize the numerator and the denominator, and then cancel common factors. Here is our example. What do we notice? We have a common factor in the denominator. In the numerator of the first term, we have the difference of 2 squares, and in the second term, we have a perfect square trinomial in our numerator. Remember, invert the divisor before factorizing. So this is what we've done. We've changed the divide to multiply, we've inverted the divisor, and we've factorized. So our x squared minus 4 factorized is x minus 2 times x plus 2. 2x plus 4 factorized is 2 in brackets x plus 2. In our second term, we have 2 at the top, and our denominator was x squared minus 4x plus 4, which we factorized to give us x minus 2 times x minus 2. And you can notice, or you can see, that there are common factors in the numerator and the denominator. So we start cancelling our common factors. X minus 2 divided by x minus 2 is equal to 1. X plus 2 divided by x plus 2 is 1. 2 divided by 2 is also 1. And we are left with 1 in our numerator, and in our denominator we are left with x minus 2. So our answer is 1 over x minus 2. We now look at the addition and subtraction of algebraic fractions. This example has the addition of two fractions, but the same principle will apply to subtraction. Our first step is to factorize. We can see that in the denominator of our second term, we have a trinomial which needs to be factorized, and this is what we end up with. X squared plus 5x plus 6 becomes x plus 3 times x plus 2. Our next step is to find the lowest common denominator. In our first term, we have x plus 2. Our second term, we have x plus 3 times x plus 2. What do we notice? X plus 2 is common to both, so we write it once, and what is left is x plus 3. So our common denominator is x plus 2 times x plus 3. The next step is to change our numerators. So if we look at our first term, x minus 2 over x plus 2, we multiply the numerator by x plus 3. Our second term, because the denominators are the same, the 3 will remain the same. We don't multiply it by anything else. Next is to simplify our numerator by expanding, removing the brackets. We end up with x squared plus x minus 6 plus 3, which can be simplified further to give us x squared plus x minus 3. The numerator can't be factorized any further, so there are no common factors that can be cancelled. Our final answer is x squared plus x minus 3 over x plus 2 times x plus 3. Finding the LCD of algebraic fractions might be a bit confusing, so let us expand on this in this slide. We will use the same example that we've worked on previously. So let us compare the two denominators. If a factor is common to both denominators, write it once. So here we have x plus 2, which is common to both denominators, which we've written down once. Next, we include all of the other factors from both our denominators. The only other factor that we have is x plus 3. So our common denominator, or LCD, is x plus 2 times x plus 3. Let us now look at how do we change the numerators once we have our lowest common denominator. So we write down our lowest common denominator, and in the numerator we write the numerator of the first term, which here is x minus 2. Now we compare the denominator of our first term with the LCD. So our first term denominator is x plus 2. Our LCD is x plus 2 times x plus 3. So the additional factor we have is x plus 3, and we multiply the x minus 2 by x plus 3, and this is what we end up with. You will notice if I had to cancel the x plus 3 in the numerator and denominator, I will end up with the first term of our initial expression. We repeat the process for the second term of our initial expression. In this example, there is no change to the 3 because the denominator of our second term is the same as our LCD. So we end up with, in our numerator, x minus 2 times x plus 3 plus 3. And as we've shown previously, we simplify this by removing the brackets, combining the like terms, and factorizing if possible.